CircuitPythonistas, it's Prof G, and in this lesson you're going to learn to use the brightness attribute of a NeoPixel object to vary brightness and create a pulse effect. We're also going to learn how to iterate through fractional values. Let's turn on the pulsing power of big learning. So as usual, plug in your CircuitPlayground board, Bluefruit or Express will do, and launch PyCharm. And if you're new to the playlist, welcome, but you might want to catch up on the prior lessons that got us to this point. Now with PyCharm up, let's start out in the REPL. So we'll head to the terminal, make sure TO is running, then Control-C to stop any programs, and press any key to get us into the REPL. The lights on your board are all white, indicating you're in the REPL, as does the triple chevron prompt, and let's create what we need to experiment. So first let's import some libraries. How about import board, time, NeoPixel, and let's create a NeoPixel object. Pixels equals NeoPixel dot NeoPixel, capital N, capital P. This is the class, and to send it to the factory between the parentheses, we'll say board dot, and in all caps, NeoPixel. That's the location of where the lights are on our board, 10, because there are 10 of them. Press return, and then we'll create a color, red equals, in parentheses, 255, 0, and let's fill that NeoPixel object with red, pixels dot fill, in parentheses, red. Cool. Now I want to show you an attribute called brightness. Try this. Pixels.brightness, press return. Mine says 1.0. That means I'm currently at full brightness. Let's see, can we turn this down to 50%? I'll up arrow for the last statement, pixels.brightness, and I'll set this equal to 0.5. Interesting. It's a little softer now. Can we turn it down to 0? Brightness equals 0.0. It's all off. How about 1/100th bright? Brightness equals 0.01. Ooh, we see a little bit in there. So that's very cool. Brightness is a fractional value that goes from 0 to 1.0, and we refer to fractional values in Python as floats. Now another thing about brightness is that the human eye can't actually distinguish between full brightness and almost full brightness. For example, try this. Brightness equals 0.8. Then try brightness equals 1.0. I don't see any difference there. Try brightness equals 0.7. So there's a small difference. So if you want full brightness, 0.8 is probably fine. It might even save you a little battery if you're working with portable projects. So now that we know how to use the brightness parameter of a NeoPixel object, let's use it in a Python program. We'll see if we can go from 0 to 1.0 in a loop. So Control-D gets us out of the REPL, and why don't we get rid of all the code that's in code.py, because we're not going to write that much. And we'll start with our first comment, pulse-up.py, and we'll import board, time, NeoPixel. We'll set up pixels the same way we did before, which equals NeoPixel.NeoPixel, capital N, capital P, and in parentheses pass in board, dot all caps NeoPixel, 10. Then red equals in parens 255, 0, Let's create a black equal to in parens 0, 0, and we'll say pixels.fill in parentheses red, R-E-D. Bit of a warning, one of the mistakes that I make sometimes is I forget to set an initial color, and I wonder why things aren't working. So remember, you've got to fill things in with an initial color before you see anything happening. It's a common mistake I see some of my students make as well. And I'm going to add a print statement that says print program is running just before the while true loop. It's nice to put something like this in here just as a confirmation that your code is in fact running. And now let's try our while true loop. So we can say while space capital T true, colon, and this will be for the pulse up. We'll put a for loop in here. Now watch what we're going to try. For I in range, and why don't we try 0.0, 1.01, 0.01, and colon, and hey, I'm getting a yellow warning. What's up with that? Well, if we hover our cursor over any of the yellow highlights of the three values in the range, it says expected supports index got float instead. This is PyCharm way of warning us that the range function expects an integer value, and it can't work with a float, which is a decimal value. And just to see, let's finish this out and run. So indented below the for loop, we'll say pixels.brightness equals I. Then we can open the terminal with TO running, save, and we got an error. Remember, you might have to scroll up to see it. It says track back where the error occurred in code.py. For me, that's line 12. It should be your for in range line. It says type error can't convert float to int. So int and float are both data types, so that's what a type error means. And this is CircuitPython's way of saying, hey, you needed an int in the range and you tried to use a float. And pro tip, after scrolling up to see results or errors, scroll back down as far as you can go. Otherwise, when you run again, you won't see the results scroll by. You'll remain where you are, and you'll wonder, hey, how come I'm not seeing anything? So we got the error because we used floats or decimal values in a range in the loop line. We can't do that. How can we fix this? Well, we'll increase the range value and then perform a little bit of math. If we want to go from 0 to 1.0 by 1/100ths, we're essentially going through 100 different values. So why don't we change this to a range from 0, 101. Remember, it's 101 because we never get up to whatever the last value in the range is. So this actually goes from 0 to 100, and we don't need to enter an increment because it will default to 1. And actually, if we don't have a start value in here, we'll start at 0. So I could have just said range in parentheses 101. So now that we have ints in here, whole numbers with no decimals, those yellow warnings have gone away. And then when we get our value I, we'll just divide it by 100 before we set it to the brightness value. So using this technique, we get values from 0.0 to 1.0, incrementing or stepping by 0.01. And we save. And this is looking great. Look at that pulsing from 0 up to 1, then back down to 0, up to 1. Perfect. Now time for a challenge. Create a function called pulse that accepts no inputs and returns no values. Pulse should start at a brightness of 0.0 with pixels filled red, increase the brightness from 0.0 to 1.0 by 1/100ths, so that's 0.01. Then, once you're at full brightness, go down from 1.0 to 0.0, also in increments of 1/100th, and repeat over and over by calling pulse in your while true loop. Save as pulse-up-and-down.py. You should know how to do this. Pause. Give it a shot. And when you're done, let's compare answers. So in PyCharm, above this print statement here, let's create our function def pulse, open and close parens, again, nothing being passed in, colon, then highlight and cut out what's in the while true, and paste it into the function. And just to show you, we can set the range to 101, cutting out the start value, which is 0 by default. And then below this statement, outdent, so this next for statement is even with the for statement above it, but still inside the function, we'll create a for statement to go in the opposite direction. So that's going to be for I in range, and in parentheses, since we want to go from a larger start value than our end value, we need 3 values in here. The start value, the stop value that we approach but never reach, and the increment value. In fact, one of the nice things about PyCharm is it actually tells you that here. It calls it start, stop, and the last value is called the step value. But that's your increment value. So start is 100, comma, end value is -1. We'll never reach -1, comma, and -1 is our increment value. So we'll approach -1, we'll stop at 0. Make sure you got a colon at the end. Then the body of this loop is the same as the one above. Pixels.brightness equals I/100. And let's not forget to call the function, always a frequent source of frustration, wondering why the code is not running and then finally realizing that you didn't call the function. So indented inside the while true, we'll just say pulse, open and close parens, and save and run. And look at this, we're pulsing up and down. Nice! Don't forget to save this as pulse up and down, and to close the extra tab so you're back at code.py. So in this lesson, we learned how to use the brightness property, and we learned how to create ranges that would get us to decimal values, even though ranges can't accept decimals. Now in the next lesson, we're going to learn how we can pulse and play sound at the same time. Until then, continue to hack.